Kaylin did blue, Owen did green, and Ethan did purple.
Okay, so before we used to just approximate it about making it, we used to just make endpoints and put the midpoint in the middle of the points and just say it's good. But now we'd make a line with the endpoints, and then we would make bisectors, or we would measure it out. This would secure it and make it more exact in the middle of the points.
We think that Kaylin's midpoint, which was the blue one, was the best because when we lined it up with a straight ruler, it lined up with the 3 dots the best. And because we took a piece of paper and used the length's edge, another reason is equal distance from both of the endpoints.
The blue facts, as you can see in this video, the line at the endpoints go through the midpoint, and the distance through the midpoint to the endpoints are both each 8 and 5/10 centimeters.
For the green facts, we made a line with the endpoints, and it was straight through the midpoints, but in the midpoint distance, one side was 9 5/10, and the other was 10 centimeters away, so they weren't equal, but the line, it was on a straight line.
You just want me to, yeah, just go. It's fine.
Yeah.
Okay. 10.5 centimeters away from the midpoint each.
But it didn't touch the midpoint at all. And the distance is also 8 on one side and 9 on the other, so it wouldn't even be compared to the other.
Ideas for how to make a midpoint, like a midpoint, is to use a ruler. Is that a video?
Yeah.
Or yeah, make a line.
Our second idea is to make a bisector.
Purple is a midpoint too, because the endpoints are just 1 centimeter difference.
To conclude, we chose blue because the line goes straight through the midpoint, and the distance from the endpoints and the midpoints are the same.
Will Pham, Amit Kumar, and Matt Willis.
Change in thought. At first, we believed midpoints were points that were the same distance from the endpoints but didn't have to be on a straight line. Throughout the unit, we discovered that midpoints were points on a line that is the exact center of the line segment. In the beginning, we thought that the purple midpoint was best. After checking with several methods, we found the blue midpoint the best.
What midpoint is mathematically the best? We believe that the blue midpoint is the best. We had several methods but chose a few main ones. We tried many methods to finding the best midpoint, but the main ideas we used were perpendicular bisector, the midpoint formula, and using a ruler.
First, we traced each of the sets of dots as accurately as we could. Next, we found the radius of each dot with a ruler to find the exact center. Afterwards, we connected the endpoints of set of points. Then we checked to see if the point in the middle was intersected by the previous lines. We also measured the distance from one point to the other. Another way we checked if the midpoint was in the middle was by using a compass to find the perpendicular bisector. We decided that the blue set of points were the best because the midpoint was the closest to the middle, and also because it was closest to the line created by connecting the two endpoints.
First, we plotted each of the sets of points as accurately as we could. Next, afterwards, we used the midpoint formula, which is that, and then to find the midpoint. After we calculated the midpoint, we checked to see if it matched up with the one we plotted in the beginning. The result ended up having blue the closest to the calculated point.
I think the blue midpoint was the best. We know this because using the midpoint formula and perpendicular bisector, throughout all of our results, we found that the blue always came in closest to the actual midpoint.
Which midpoint is better? These are our materials. For this, we used an expo marker, a pencil, a protractor, and a compass. And this is our basic process. So we want to start out with these 2 dots on a line. and then a dot in the middle. So you want to determine if this midpoint is going to be best. To do that, you're going to need a compass, and it's going to make the line about halfway through. For this example, we already finished it, where you just make the X's on both sides. From those X's, you want to draw one line from the top of the X to the line to the bottom of the X, straight through your midpoint. If that line goes straight through your midpoint, then your midpoint's good. If it's a little off, or if it's off-centered, then your midpoint's not the best it can be. And that's the basic explanation.
In our last video, we said it was a dot lot, but really, it's a point. This is our complete process of how we found a midpoint. But don't worry, we'll speed it up.
So fast.
This is how we found which midpoint was truly best.
After using our process on both pieces of paper, we made the bisectors and we just studied which dot or bisection would be closest to the initial circle. So we assumed that the 3 circles were all on a straight line, even though some of them weren't. We did it twice to make sure that we had accurate results. And after inspection, we realized that this one right here and this one right here, which is the same ones, had the closest bisector to the center of the circle, as it was pretty close right there. And over here, it was pretty close as well.
This is our group's PBA, PBL answer, and our names are Elizabeth, Trev, Bryce, and Liam. Our note at the bottom says that PSL stands for perfectly straight line, and PBI stands for perpendicular bisector.
So our idea to find the midpoint was we would find the perfect midpoint by performing 2 tests on our examples, and the first test was to find the perfect center of the large dots and then find a straight line that would go through the endpoints and see how far off the given midpoint was from that perfectly straight line. And then we also found the perpendicular bisector of the line and measured how far off the given midpoint was from our perpendicular bisector.
Our methods were what we believed was most accurate. Some other methods we could have used include putting these points onto a graph and then using the midpoint formula on a graph. Have x1 plus x2 in parentheses divided by 2, comma, y1 plus y2 in parentheses divided by 2 to find the midpoint and the measure, and then measure the distance on the graph from the given point and the perfect midpoint. However, this could have resulted in some very hard, small measurements that would not be easy to use with our formula.
What we would have done before the unit is measure everything with the ruler and just calculated the distances, which is kind of what we did, but without the perpendicular bisector part. We also thought at the start of the unit that it just had to be a equal distance away from each of the endpoints, and it didn't have to be on a straight line. That would greatly affect the overall answers that we got. Overall, our answers would have been different at the beginning of the unit.
So first, we found the center of each dot.
Then we drew a straight line from the center of each dot to the other dot.
We then measured the distance of how far off the midpoint was from the perfectly straight line.
Then we found the perpendicular bisector and measured how far it was off the given midpoints.
In fourth place, we have a midpoint that is 0 and 3/10 centimeters away from the PSL and 1 1/10 of a centimeter away from PBI, which is a total of 4/10 centimeters away from the perfect midpoint. The perfect midpoint is.
Grady's. With 3/10 centimeters off of the perfectly straight line and 5/100 centimeters off of the perpendicular bisector, and a total of 35/100 away from the perfect midpoint, the person in third place is Olin.
In first place, the winner is the fabulous midpoint. Who do you think it is?
Ethan. Can we have a drum roll?
Drum roll. Joe!
Just kidding. The actual winner with only a 0.1 centimeter off the perfect midpoint is her. Well, I'm a her. I can be a her.
Caitlin's midpoint is almost.
On point! There we go. That was Wait, we're not done yet.
Okay, so in second place with 1/10 centimeter off of the perfectly straight line and 1,500 centimeters off of the perpendicular bisector, and a total of 2,500 off of the perfect midpoint is Ethan. Yay!
Mama, I told you we'd make it.
Okay, so here are our calculations.
So we added up the differences from the perfect midpoint, and the one with the smallest distance won.
Which midpoint is best? But why? Because it's the straightest. In order to find which midpoint was best, we found the center of each point and then found the perpendicular bisector using our compass.
In order to find the perpendicular bisector with a compass, you want to swing an arc from one point above and below. Make sure it's it's past the middle. And then connect the two lines, and then connect the points, the centers of the points. In this case, because the dots were much larger, we had to find the centers. Using a ruler, we drew lines crossing the centers of the arcs and the centers of the 2 points. Where the two lines meet creates a point, which is the midpoint. And using this information, we decided which point was closer to the actual center.
We also had another way of finding the midpoint. Here we counted the units between each endpoint. This one had 13 3/4 of a unit. A unit is defined by the length of one of the squares. We use this method by taking the length between the endpoints and dividing it by 2, because the midpoint should be exactly on this halfway mark. For this one, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units. We then did the same process for the rest of them.
Oh, there we go.
As you can see, this one is just slightly off from the center. And this one is also slightly further away from the center than this next one, which is only 2 millimeters away from the center. And this final one is the furthest from the center.
That's all.
Alright, so this is our presentation by Adam Bristow, Lisa Levy, Will Foster, and Miss Note.
A midpoint is a point on a line segment that divides it into 2 equal parts, or the halfway point on a line segment.
The change in our thinking.
At the beginning of the quarter, we would have solved this. We thought that a midpoint was the point between any line. We did not think that this line had to be straight. Over the course of the lesson, we have began to learn that a midpoint is not only a point on a line, but it must be a straight line. Also, that the midpoint must be exactly in the middle of the line. Knowing this all was the key to finding the best midpoint.
How did we think of using this idea? During this unit, we did a lot of work finding midpoints. When we were doing this, we figured out that the perpendicular bisector method gave us the exact midpoint. We got a printout of all the points and used this method for all of them. Doing this showed us how far away the middle point was from the two outermost points. That method was very helpful. Next, since the midpoint has to be in the direct center, we used a ruler to measure how far away the center point originally drawn was from the location where it would be a perfect midpoint. These were the two methods that we found most effective, and that's why we used them.
Alright, so for the red point, as you can see from the images on the right, the red midpoint was not that close to a perfect midpoint. It was not a perfect midpoint because the distance from the center point to the two other points were not the same. Therefore, it is not a perfect midpoint.
Yes, and we go back over. Like, the left side is 3.7, and the right is 3.3 7/10. And we did like a bigger circle for where the exact midpoint would be, and the smaller one is where we found it. Yeah.
Like the middle of the point.
Yeah, the middle of the.
So next. So for the blue midpoint, for this midpoint, you could see that we used the perpendicular bisector method, which is just the two lines with the swinging arches, and then but it's not quite perfect. But it's not a quite midpoint. Perfect midpoint because the distance from each point of this to the center is off by 0.1, as it says 3.6 and 3.5 on that side. Also, we used a ruler with a straight edge to determine the straight of the line, determine how straight the lines line up. That's how this lined up. Our result were that the line is almost perfectly straight and the last point off by the 1/10 of a centimeter.
For green midpoint, we said that, as you can see here, this midpoint is also really close to a perfect midpoint, but it's not. For example, when we did the perpendicular bisector, the middle point was off by 1/10 of a centimeter. Also, when we tested to see if the 3 points made a straight line with a ruler, the points did not match up to be straight.
As you can see here, this is very close to being midpoint, except for the fact that it is not in the middle of the two lines that we drew. As you can see here, the three lines, they don't match up with the dots that we made. One side is 4 2/10 centimeters away, while the other side is 3.7 centimeters away from the center point. Other than the fact that it is not in the middle, it is very close to being in the exact midpoint because the points are straight.
So what we thought was the best midpoint. So in this PBA, we were challenged to find the best midpoint out of the 4 midpoints: red, blue, green, purple. During this unit, we have found a couple ways and strategies to find out the best midpoint. Not only do we need to find a winner, we need to prove how we found the best midpoint.
Conclusion. To conclude, it is very obvious that the blue midpoint is the best midpoint. Although none of these were an exact midpoint, in our opinion, blue is definitely the closest. When we did the perpendicular bisector method and another method with a ruler, it was the closest to perfect. Throughout this unit, we have learned many things. First, that a midpoint is not just any point on a line. Next, that there are many correct answers, and there's not just one way to find an answer. These two things made it easy for us to conclude that the blue is the best midpoint. The end.